2. That way, you know, everything is with that particular lesson, and there's no confusion when I have to go through and check the homework. So here we have mixed fractions that we're solving with. Here we have 3.5 over x, and that equals to 9 1/3 over 2. And I like to go ahead and change the mixed fraction to an improper fraction right away. So that'll be 3 times 2 is 6, and 1 is 7, so that's 7 over 2. And this will be 9 times 3 is 27, plus 1 is 28. So as soon as I get this pen unstuck, get it to right. There we go. So that'll be 28 over 3. So this is what we've got. We've got 7 over 2, and that's over x. And I like to make that line that divides the two expressions larger, so that it makes it a little bit easier to see the numerator and denominator instead of, you know, that makes a little bit of difference than having it like that. Then you're kind of wondering, well, what's the numerator and what's the denominator here? So I just like to exaggerate where the numerator and denominator are. Equals to 28 over 3, and that's over 2. Okay, now what do you think we do?
I'm lost. I tried to do it. You got to make both sides even. Is that what you're looking? You're looking for what x is.
You're solving for x, right?
Yeah. Are we going to take them fractions and turn into decimals?
No.
I thought that too.
Something similar to what we did up here.
Yeah, distribute it.
Something similar to what we did up here.
Multiply.
Cross multiply, right? So we're going to cross multiply.
Oh, okay.
And so now this would be, we've got whether you have the 7 halves times 2 on the left or x times 28 over 3. That, it really doesn't matter. Okay, so here we have 7 halves times 2. And that equals to x, and that'll be, or you could put usually 28 over 3, the number or the coefficient goes before the variable, just for consistency. Okay, now what? Let's look at this left side here. Can we make life a little bit easier?
2 will cancel.
The 2's will cancel, right?
So it'll leave it 7.
Then all you have left is 7. So if we want to make life a little bit easier for ourselves, we would definitely want to try to do that. Okay, so that's 7 equals to 28 over 3 times x. Okay, now we got to do something with this denominator, with this 3. Anytime when you see a denominator like that, you want to get rid of it. Well, the 3 is doing what in relation to the 28 and the x? Is it adding, subtracting, multiplying, or dividing? 3 is dividing. So the opposite operation of that would be to multiply 3, so that the 3's cancel. But the problem with that is you can't just put a 3 here. If you're going to do that, you have to make both sides balance. So if you put a 3 here so that the 3's cancel, then you have to put a 3 on the other side as well. Okay? And so whatever you look at, okay, what am I doing in relation to x? Am I adding, subtracting, multiplying, or dividing? In this case, we're dividing, so we want to do the opposite operation, which would be to multiply the 3. So we multiply the 3, but if we multiply the 3 on the right side, we have, or the the right side, we have to multiply the 3 on the left side as well. Okay, so the 3's on the right side, you got, it's 3 over 1 times 28 over 3, so the 3's cancel, just like the 2's canceled here. Same process is going on. So now we have to multiply 3 times 7, and that's going to be what? 21 is equal to 28x. Okay, now this x is, we're trying to solve for x. We're trying to isolate that x. We're trying to get that x by itself. So we have to get rid of that 28 somehow. Now, what is that 28, what operation is that 28 doing in relation to the x?
Holding it up.
What?
Good question.
It's
Is it-
holding it up.
Holding it up. Well, is it adding, subtracting, multiplying, or dividing? It's multiplying, right. So the opposite operation to get rid of it would be division, right? So we can't just put 28 over 8. We just can't divide 28. We just can't put, okay, I'm going to divide 28, and that's all. Can't do that. But what you can do is what you do to one side, you can do to the other side too. If we divide 28 on one side, what do you think we have to do on this left side?
Divide 28 on
Divide
that side.
28, right, to the other side too. Okay, well, why does this work? Well, what happens to the 28s on the right side? They cancel, and that's what we want. Okay, we want those 28s to cancel, and what do they cancel? When they cancel, what do we have left here? 1, right. Okay, so now this is just 1x, or you can just put x. Can we simplify the 21 and the 28? Well, let's see, 21, factors of 21 are 3 times 7, right? Factors of 28, let me do this in blue. 3 times 7, factors of 28 are 4 times 7, right? So yeah, in fact we can cancel, right? So we can cancel so that what we have here is the 7's can cancel. Right, so 7 and 28 they cancel, and we end up with 3 over 4.
Wow, who made this up?
I did. Who made this problem up? I did. You mean the concept? Well, apparently it must be important because to solve problems, I'm sure. Real world situations are not nice and neat with, nice and comfortable integers. It gets
Wow.
messy where there's fractions, and sometimes
Where do you use this at though?
Yeah.
To build a computer or something?
well, apparently there must have been, for example, you can use this in actually cooking,
How?
in figuring
I
out
don't have time.
different measurements. If the directions say to use 3 cups and 2 cups, and you only have 2.5 cups of flour, you want to come up with the right ratio for your different
Times
mixes.
called dominoes.
What's that?
Called dominoes, ain't for
Oh, all dominoes,
That
yeah.
makes sense, I understand.
Yeah, I understand what you're saying, but you're gonna do another one, right? Well, you're still not done with that, you gotta divide the 4 into the 3.